music, right? Hey, Betsy. So do you have 2 drinks for yourself, Betsy? It's only 1 hour, huh? Okay. Well, welcome everybody to the Innovation Café. And today we have a special edition because it's Dutch Design Week. And my name is Charlotte Groen. I'm a social designer based in Eindhoven. And I moderate the Innovation Café every month. And every month we have 2 speakers, always a designer and someone from tech. But today it's a bit different. We have 2 participants from the exhibition that is shown right now. But first of all, I have a question for all of you. Who is here for the first time at the Innovation Café? Ooh. Yeah. You have to come more often. Okay, and who has here been before? Yeah, all the other people. Yeah, that sounds good. Okay, well I have 20 time? 40 time. Okay, yeah. Okay, for the people who are here for the first time, the program is a bit like this. We have 2 speakers, the regulars. The program is like this. We have 2 speakers. They will present their work. And the work is already here and also part of the exhibition. And afterwards, we have time for questions. And even after this hour of speaking, we have some drinks for the informal conversation and also a design dinner, which you can join. Well, let me tell you something about today. We have two, very nice speakers today. Jean-Marc. So I told you, when I get nervous, I always, it goes wrong. And Antonia, welcome. And what you guys have in common, which is quite interesting, because I asked Annemone, why did you choose those 2 speakers, is that you both do material research and searching for new materials. And the one is doing material research about shit, and the other one about scrap. So this is going to be a fun Innovation Café. So please give a big applause for Jean-Marc and Antoinette. Come on, please join. Yeah, Jean-Marc, we will start with you.
Yeah, thank you.
Welcome.
Thank you.
Because which project is yours?
Absolutely. And I have a bad news. I'm not a designer. I'm an engineer.
Okay. But still, you have
But
to
the good news is that I'm surrounded by designers. Also at home. And my mission with our colleagues is actually to make them think about saving our planet and helping the people for better communities. And what we have here actually, and there is indeed a lot of similarities with what Antonia is doing, is that we use...
Please turn around because you have a lovely back.
Absolutely. But we use actually scrap. Dirty scrap, not the nice scrap that you can have from operations, but the scrap that you have from what we call urban mining. And we use that to transform that into an object. And one of the objects is that one. You may say, well, it's just a seat. Yeah, but you are also actually on a seat. I'm sure it's not as comfortable as that one. There is a bit of plastic, a bit of coating. I'm not sure it is really sturdy. Long-lasting, and if you will need to recycle that one, I'm not sure if you will get a lot from that. So this is what we have, this is our philosophy when we help designers and people to develop objects or systems and to think about the whole life cycle. And not only about the material, but all the environmental impacts, including what we call eco-design. And this is a fantastic seat.
But I already have a question.
Yeah.
Because you normally don't design chairs.
9.
Your company is called
it's yes and no.
Hydro.
Yeah. We don't design directly. We support. We have designers as well in our company, which help companies or people to develop their stuff. But there are cases where when we are asked by companies also to do the full design. So we have not only developers and engineers, but also truly industrial designers in-house.
Okay.
Yeah.
Okay.
And that's where some of our colleagues are able to talk peers to you guys.
Yeah. And your project called R100.
Yes.
Can you explain that a little bit?
Well, we are extremely creative because 2 years ago it was called 100R.
Oh.
Yeah?
Okay.
This is when we launched the raw material.
Okay.
The raw material. Well, you could also show your sheets. I show my horse crap. So it's based on an aluminium that is produced by using 100% of post-consumer scrap. Aluminium has always been recycled for many, many years, or even more than 1 century. Mm-hmm. But recycling post-consumer scrap, the scrap that is coming from objects that have seen a life, as a window, as a wheel hub, as a chair.
A light pole, I've heard.
Yes, everything that is made in aluminium. When it is coated, when it is unsorted, it's a challenge to recycle. And of course, when you go to a high percentage, certainly 100s, well, this is a big challenge. So you may wonder, why do we do that? We could just dilute that post-consumer scrap with regular scrap and primary metal. That's because first we are crazy, two, because we want to break boundaries, and we wanted to create the lowest environmental impact and carbon footprint aluminum in the world. So this is what you have here. That's the lowest that you can have, without offset, without artifices, without virtual allocation.
Okay.
So that's 100R.
Okay.
Now the R100, R for radius. We have recycling cast houses a little bit everywhere in Europe. So you could say, oh, you are large, you are a big company. Yes, but we do have smaller sites. We prefer to be local. And so the R100 project, all the scrap that is used to produce that aluminum is within 100 kilometer radius around the cast house. So it is really local urban mining.
Okay, and where is it produced? We know where the raw material is coming from, but where is it produced?
This one, I believe, is produced in Vetlanda in Sweden.
Ah, okay.
But it could be produced in Drunen in the Netherlands, Harderwijk, Hoogezand. That's also a good question because we do have a lot of extrusion sites, 35 in Europe. Again, because we prefer to be close to our designers and our customers instead to have a gigafactory somewhere.
Okay.
Yeah.
But I'm also very curious because we will come to you in a second. Why, for you in a person, wanted to start recycling?
Just because it makes sense. If we are on a planet and we have boundaries, it's our sky, so we cannot extract indefinitely. Mm-hmm. So we have to recycle if we want to avoid issues in the near future. And for some raw materials, the near future is within 20 to 50 years. So that's why recycling is key. And also for us, recycling post-consumer scrap is the fastest way to decarbonize. As I told you, you may not have values in head, but the 100R, the Circal, this alloy that we have used to make that chair has a carbon footprint of 0.4 kilo CO2 per kilogram.
Well,
I will just give you one other value to compare is the average worldwide is 15. That's the average worldwide, 15. So here we are at 0.4.
Okay.
Without offsets, without gimmicks, it's purely straight and real accounting and traceability as well because we have a system in place to know where the raw materials are coming from. A small QR code and you scan.
And then you know.
And then you know.
Wow. Thank you. Antoinette, please tell us about your work. Well, we know you couldn't bring your raw material because it's shit, but please tell us, because you are also a award-winning designer. Huh? You just graduated from the Design Academy and you're already award-winning designer.
Yes, I don't know.
Is it?
Yeah, thanks. Hello. My name is Antonia. Yeah, I graduated last year actually at the Design Academy, and this is my graduation project, which then was nominated and won the Kazerne Design Award. And
wow!
Sorry?
Wow, that's amazing! Yeah, big applause.
Thank you so much.
Yeah.
And it's a simple concept. It's the idea is that we can build with everything, even with shit, And I was on the quest to find a way to waterproof clay, because in the Netherlands we don't really build with clay, because probably most of you know that clay is dissolvable in water, which makes it also one of the, in my opinion, best building materials because it's 100% recyclable. But in the Netherlands we have so much rain that a house from clay would never withstand. So I thought, aren't there some ways to make it more waterproof? And one of the ways I came across is using cow dung, because in cow dung there are fatty acids that create like a water repellent effect. And actually this technique is used in a lot of Asian and African countries, but here it's not so common. And I wanted to, first of all, try it out, see how it looks, how it works, and also to bring it in a new architectural context, because often when people think about clay houses, they think of like round hippie houses with like glass bottle windows, but I wanted to stretch that thought into like modern architecture, and that it also can be aesthetically pleasing. And this approach is about plaster. There's also other ways in the building industry, like bricks or floors.
Wow. And how did you came to plaster? Because
I think I was just as a child already very passionate about renovation, and I was plastering a lot, so I think it's like a personal connection also. But now I'm also working towards other directions, so I think it was my starting point. And I think it's also like the outer shell of a house, so it says a lot. This is the idea to use as a facade.
yeah.
So yeah.
And I see two different colors.
Yes.
What is the difference between it?
So this part is only made from cow dung, sand, and clay, and this part is also waxed with a linseed bee oil wax, and it's because cow dung is stabilizing it, but I wouldn't say you can put this for 3 weeks in pouring rain. So I'm also still on the hunt of looking into even more biopolymer stabilizations to make it more waterproof. But then once you start using oils or wax or other polymers, it gets really expensive. So it's about finding the balance between like as simple as possible, but as complex as needed.
Yeah. Oh wow. And I will smell it because it is. I've tried it before, so I won't. It's okay. You don't smell anything about it. Like I wouldn't, like lick it or something. But it doesn't smell like cow shit at all. And wow, it looks really nice. I'm also curious, because this morning we had a lecture. I'm not sure if anybody was here about from Liedewij Edelkoort, who was presenting her book, and it was about craft. And I'm so curious that you said I want to make it like very clean, so we can also use it here in the Netherlands or also in other places, or what do you imagine for your...
Yeah, I think if you give too much personal aesthetic to a product, it's not really made for the whole market. So I think when you, like in terms of material design, I think it makes sense to start very minimalistic and then expand into a more experimental ways of designing with it. But I wanted to, because this is just a starting point, like I wanted to just start from a very simple minimalistic aesthetic, so then people can see and be convinced and maybe try out themselves. My idea is also that I am not the person who will change the world with this, like it's not even my recipe, I just found this. That's why I also think it's important to share and inspire other people to use the same, and someone else can make another design.
So this is also open source recipe.
Yes.
Is your recipe also open source? Yeah, we have to.
Yes, it's just 100% scrap.
Okay, just 100% scrap.
Yes.
That's
But
perfect.
you have to select and to sort the scrap. This is where our proprietary information intelligence is. But I like what you said about the fact that it's a test. It will be developed. It was a test because no one did 100% post-consumer scrap before, or only laboratorium. Because once you start to produce something like that and transform that into an anodized or painted profile, you may have issues with your metallurgy and the alloys and all that. And by doing this and by doing that, by starting small, then you learn, and then you have customers, designers that test, they have ideas, they want, because this is the classical anodized color. It's gray. It's nice, it's dull.
Yeah.
But when we started with some of your peers, designers, 2 years ago with this product, they said, yeah, but gray is dull. We want blue.
Yeah.
And, but blue is we made it. So
How did you make it?
Well, I don't know because I'm not a specialist of
okay.
anodizing, but actually the designers, they insist that we don't want to see your
Gray.
class, I would not say shitty colors, but gold, silver, We want to see orange, yellow, red, blue, with nice pigments that are sustainable in the time, also sustainability sourced. And actually, the anodization was made in the Netherlands because the knowledge was in Hoogezand.
Ah, wow. Nice. And there's also a little bit of a link between the two of you because you only use extrusion, right, for your aluminium?
Yeah, so that's also part of the eco-design process. We love metal, we love aluminium, we want to sell a maximum of aluminium. No, I'm joking. We want to reduce the costs. That was also one of the drivers.
Yeah.
And so what is quite expensive when you extrude aluminium is to create what you call the die, the shape that will actually form the profile when it will be extruded. So here, I think it's version 2, so we have 2 profiles, but the first version of that seed, we had only 1 profile. Of course, it's bended and cut different way, but also for the customer, this is cheaper than a version where you will have 3 or 4 or 5 different profiles. So we limited that to a minimum amount of dies, and also the screws, they're all the same. And yeah, so that's, so it can be stacked. So yeah, there are some smart things that you don't see, but that were thought during this eco-design process.
I'm also curious, because there are I saw more products also designed by bigger names like Sabine Marcellus and I'm sorry, I forgot the other names from the exhibition. The other designers who also designed objects.
Lars Willem and
Yeah, and why did you choose to do that?
Why did we choose them?
Yeah.
Well, because at that time they were famous, but we have also designers that came to us.
Okay.
We like to work with young, less young, famous, less famous designers. I'm a bit jealous of you because you are a designer, but you speak like an engineer, like a chemist, which proves once again that designers can become engineers. I'm not sure that engineers can become designers, so I tried, but I'm not good at that. But yeah, I mean, we like to work with different type of designers because ideas are everywhere.
Yeah. Okay. Wow, that's a big compliment for you. Huh? Yeah.
Thank you.
Yeah. Are there any questions from the audience? Yes. Yes. What is your name?
My name is Kento. How long I have 2 questions. How long did it take for you to develop that chair, and how long does it take to go from like a scrap piece of metal to a full chair?
That's a good question. So for that one, it was very fast. It was a fast process because it was actually designed for the Milano Fair, and usually it's 1 year. But your question is interesting because if you think about a full-scale product, it can take 6 months up to 2 years. Development if you have prototypes and versioning and all that.
Okay.
What was your second question?
How long did it take?
I answered that.
Yeah.
From this to that.
Yeah.
So I will answer. Tomorrow, I am in Clairvaux, in Grand Duchy of Luxembourg, which is my home country. I will visit one of our cast houses where we produce that. So if you give me today scrap, I will bring it tomorrow. I will put it in the furnace, not myself, but I will ask someone. Then it will be transformed into a billet the same day, and it could be sent to Druden or Hoogezand the day after. So if we want to make it super speedy, a couple of days.
A couple of days.
Yeah.
And how is that for you? How long did it take for you to produce this?
Depends how warm it is, because you work in 2 layers, but 2 days, because, yeah.
And what does the heat have to do with it? Or
The drying time, like the mix you can make in 1 day. Some people say it's better to let it ferment a few days once you mix the cow dung, the clay, and the sand. But I also used it directly, and then if it's summer, you can even apply the second layer in the same day.
Wow, wow. We have another question.
Hello, my name is Steven. I have a question for Antonia. I guess you experimented with different kinds of manure or different kinds of shit. Did you came across surprisingly differences between the different kinds of... And what kind of manure or kind of shit did you experiment with?
Yeah, are you a farmer or a manure expert?
No. I'm an engineer and a musician. So
okay, great. I experimented with mainly like in terms of physiological differences, the compact manure that you can find on the field, which is mainly the poop, and then the slurry, which is like collected under the stables, which is also mixed with the urine. That one is much more smelly, and it has smaller fibers, and the compact one has bigger fibers, and it results in a darker color. This one is made from the slurry. So with the slurry, you can actually make like really smooth surfaces because the fibers are filtered through the gutter. But I also used manure from different farms. These panels, and I think this one is actually made from a conventional farm from Arla in Deurne. And the other one is I used biodynamic manure from a biofarm, the Genneperhoef in Eindhoven. The difference is the smell, because the cows eat something else. Like the conventional farming, they give them mostly like seeds and like mice and these things. So you also find that in the manure. But the biodynamic farms, mostly they are outside in the best case. So you find mainly the grass fibers. So that makes a difference. But I think they all work. And the project has also like a political idea that because in the Netherlands we have a nitrogen crisis and a lot of farmers have to pay to get rid of the manure, while the biodynamic farmers use all their manure for their land. The conventional farmers, they have more manure than land to fertilize. So the idea is that you use that surplus to make products like this.
Okay. You meant that there's also different animals.
Okay, yeah. I also tried with horse manure, but it doesn't have the fatty acids, so it's something particular to the gut of the cows that works specifically well. It's really crazy. I thought that the horse manure would do the same, but it actually doesn't. I didn't try other than horse and cow.
How do you collect the shit? We know how you collect it. Well, a little bit, but maybe I'll ask the question to the both of you. You first.
Yeah, I go with a bucket to the farm and I say, can you fill it up? Or I bring my shovel and then...
You just take it out of the grass and you put it in?
Either the compact one you can collect, mostly they have it piled somewhere, or if you want it really fresh, you just go to the field. And the slurry, you have to ask the farmer, because they have mostly like a hole where you can access, because they also pump it into the trucks to fertilize the land, and then you can just fill your bucket.
And you also told me that there's in the slurry there's more urine, right? Urine. Thanks. Yeah. So that it is also different.
Yeah. In some recipes they only use urine to stabilize actually plastic. I think it has stabilizing effects, but not necessarily waterproofing. I think the manure really has this the fatty acids, so that's what you really need.
Yeah.
So yeah.
Wow. And for you, because you don't go to the
No,
to the
but,
fields to collect your aluminum.
We also have stabilizers, not urine. Well, when we say it's 100%, we lie a little bit. It's 99.99. There is 0.01% of grain refiners.
Okay.
Yeah. Well, how do we collect?
No, well, I also heard from your colleague that, for example, the light poles that you sell,
Yes.
for example, to municipalities,
Yes.
that they can also, when their life cycle is over,
Or when someone drunk crash his car on it.
it's
yes.
scrap. It becomes scrap, and then
The light mast, not
Yeah.
the car. Yes.
And I've also heard that they can just sell it back to you, that you sell the material back.
Well,
kind of.
yes, that's, and Leopold is here. It's the closed loop that you have set up with Dutch municipalities. It's unique, actually. No, yeah. So the light mass will come back to Drunen, to Paul Product Hydro. Leopold was the boss, and he set up that closed loop business. We learn a lot from that, by the way. So that means the light mass, when they are worn or damaged, they are coming back, and they are either refurbished, they upgrade it, update with maybe newer equipment, new LED lights, and when it is too damaged, it will be recycled, and then in a tolling agreement, that aluminum will be reused, scrapped, and remelted, and re-extruded into new tubes that will be then transformed into light mast.
Okay.
Yeah. So it's a closed loop. And the speed of the closed loop depends on what happens with the light mast.
You also have to find a way that they will bring the shit to you, huh? Before you recycle it. That will help you. Yeah. You had a question?
Sure. Actually, two questions to Antonia. So first of all, the material I think, is known to be flammable. It's used, flammable, yes. It's used as a very efficient fuel historically.
Cow manure, you think?
Yeah.
You say? Yeah. It's also pressed into pellets.
Yeah.
So because this is like a pilot project, once you want to really bring it on the market, you have to meet a lot of standards.
Okay.
So I'm pretty sure that this recipe will not make it on the conventional commercial market. So you need probably to stabilize it differently and to make sure that it meets all the requirements.
Okay. And you mentioned something about the role of fatty acids. Could you elaborate on that, please?
The role of fatty acids?
Fatty acids, yes.
Yeah, I'm not a chemical expert, but the idea is that in the manure there are like chains of fatty acids that, especially when the manure is wet, like you have to use it wet, you cannot dry it, because if you dry it they would break. I think the movement also of mixing the clay kind of charges the molecules in the plaster. So it's kind of like a probably super complex chemical process that happens. But on a chemical level, I think it's that the clay particles are like kind of discs. And act as the binder, and the sand fills the gaps, and the cow manure has the fiber. So it's like the perfect combination of three materials coming together, and the fatty acids are just like giving this kind of lotus effect to the material. Yeah. Sorry, I cannot go too much.
Wow. But we also have like drinks afterwards. I have to continue this more in depth. Yeah, Betsy.
Hi, this is a question for Jean-Marc. My name is Betsy, and I kind of think about things from a different angle sometimes in terms of like the financial or technical aspect. And I'm wondering, you mentioned the proprietary aspect of your business. Is it around the sorting of the aluminum? Because I know a lot of businesses who do plastic sorting, and they use, like this company does a technology called MadScan, and they scan plastics as they come in, and they use an AI technology to kind of pick and sort. Is that kind of around?
Yeah, all these technology that we use, X-ray, spectroscopy, AI, vision, to sort. Because when you collect scrap, it can be, the aluminum is actually never the same. You have always difference in the alloy elements. So if you have a 5,000 or 7,000 alloy, you have to segregate that and to sort that. Yep. And so you have to develop advanced technologies to do that in an efficient manner, but also fast and cost-effective. So it is by mixing these technologies that we can separate the scrap flow, the chips, into different buckets, depending on the alloy that we will produce. Here it's a 6066, I think, or maybe 6082. Leopold? Okay, yeah.
Very cool. Okay, we had another question here. I saw someone. Another question, Steve.
Another. Yeah. Steve. Yeah, it was just kind of a fun question about you collect a bucket of shit, and then you travel by bus back to your laboratory or by train.
No, it's a really funny story. I borrowed my friend's bike trailer, and I put a bathtub in it. And then I put a lot of buckets and I traveled to my atelier with the bike, but it didn't work so well. So then in the end I pushed the bike. So it was like a smelly bathtub going through Eindhoven.
It's too bad you don't see his face, but you see the image still there.
I arrived very sweaty.
Sweaty.
But also at Design Academy, sometimes I had to travel in the elevator with a bucket of shit. And the people were always like, what is smelling? But no one really dared to say anything. It's like, yeah, I have a bucket of shit here.
I think you should design some kind of sticker. That is correct. That it's like
a
caution.
shirt.
Yeah. It's me. Sorry. Yeah, you had a question. Sorry, I missed you.
Thank you. Hi. I would like to compliment you on your sustainable material development. But for me, it rings many bells. I mean, thinking about the old Egyptians 5,000 years ago making bricks with also, what's it called, ballast, straw. I guess you find that in the cow dung and so forth. And burning, simple burning it once to make it really strong and so forth. So how did you, in your project, refer to history, find, in your research, how did you inspire by history and references? Yeah?
I just read through a lot of mostly scientific papers, and sometimes I came across like techniques or materials that were used like long time ago, but also in a lot of countries they are actually still used. I will not go too far in it, but one material or technique that I encountered was zarouche, which is so unknown, but it's actually very fascinating, and it's from like Oman, Iran region, and it was developed before concrete, and they also use cow dung. They make discs, they dry them in the sun, and they stack them in like a furnace shape, or like a, no, not furnace, kamin, chimney shape, and they burn it, and because the fire gets so hot, they kind of create like a very strong pozzolanic material, and then they made these canals for the palm plantages for it. So I think during all the years of research I did, I often encounter these techniques, and I'm very inspired by it, because it was often used without crazy machinery or heat, just by like smart engineering, very low tech. And in this case, I didn't burn anything, and that was also the aim, to try to make a material that is waterproof but not burned, which is quite a quest actually. So I was surprised how well it worked.
Okay, we have another question here.
Hi everyone, my name is Paul. As the title says, sheet scrap and something better. Do you consider mycelium to be a something better thing as an alternative to sheet and scrap? Thank you. It's a question to both of you, actually.
I think mycelium has a lot of potential. I think the people who go into mycelium, they never go back. That's why I didn't do it, because I still wanted to explore some other pathways. Yeah, I really believe in mycelium, and I think it will, the next years, like be crazy evolutionary progress, actually.
Okay. And for you?
We believe we can improve as well. Probably not in a percentage, because it's already there. But in different applications, mainly automotive and transport application, where the alloying elements are extremely strict in terms of copper and all that, which may be difficult to achieve with 100% post-consumer scrap. So this is where the research and development is taking place with metallurgists. And then on the process itself, we need heat to melt that, actually. Not a lot, but still 700 degrees. Also in the process, instead of using gas to melt the scrap, to use, for instance, green hydrogen or biomethane. We discussed about the methane that is in there, in the raw product, will be transformed into biomethane that we could use to melt scrap.
Okay, but can you also reuse the reusable aluminium in the same way?
Yeah, it's most metals, if not all metals, are permanent. So the way the atomic structure is done, phase cubic centered for the aluminiums, which means when you remelt it, and when it's going back to its solid form, the atoms will always go back to their original crystallographic position. So that's why metals can be recycled again and again.
Wow.
The challenge, of course, is that you have contaminated elements in that. When you recycle, it's never 100% pure aluminum. You have the legacy alloys, and then you have also impurities and all that. So there also we have to have specific processes to get rid of that.
Okay.
Yeah.
Okay. Ernst.
I have two questions regarding the cow dung panels. So we heard already about the challenge to make it waterproof, and there's maybe also a fire safety issue. What other challenges do you have to overcome to really implement it in a building, let's say here in the Netherlands? And the other question is related to the recycling or disposal. So for metals, we just heard, they can be used indefinitely. But how would you dispose these panels? Can you just put them on the field like cow dung, or is something else necessary?
Okay, the second question I can reply really fast. It's so this right now is just clay, sand, and cow dung. So you could just maybe smash it with a hammer and then throw it in the field. It will not do any harm. And the first question, remind me.
What needs to happen? What are the open questions?
I think right now there's still a big image problem. First on clay, that people don't trust clay in the Netherlands, like talking about the Netherlands. And also people don't like shit. They like, if you ask, we did like a group of students did a questionnaire, so they showed this material to people, and first round they didn't know what it is, and they asked, would you apply this in your house? And a lot of them said yes, and then they knew that it was made with shit, and then mostly the people said no. Even though you cannot smell anything, but it's, of course, people don't like the idea. So I think that's also a quest. And probably, to really bring it on the market, it needs to meet a lot of standards, requirements, where it gets really complicated.
Engineers.
Yeah.
Engineers.
You know everything about that.
I think step by step, you can solve a lot of problems. All hopefully.
Ah. What is your name?
Hallo, ik ben Marianne. Een van de dingen die van poep gemaakt worden. In English also. The paper they make in India from shit is very famous. And in the beginning they had the same problem because it was made from shit. And then it became a hype to have paper made from shit. So.
And how did they create the hype? Do you know?
I think because of the younger people, they think it's funny.
Yeah, I think humor is always a good way to sell. And in India, I know they also apply it much more. And they have even products on the market that use dry cow manure, like mixed with other things that are maybe not so good. But I think in India it's way more accepted than here, unfortunately.
Hi, it's Kento again. Kind of a follow-up question to both of you. How much do you think time factors into your sustainability? Because earlier both of you said you need like minimum 2 days to make it. And I was thinking, well, okay, you need 2 days to make it compared to an injection molded chair, which takes a couple seconds. And then you also have to transport these chairs and panels, which are more fragile in your case, and in your case they're heavier than plastic. So do you think it's like a solution that can fully, I guess, catch up to the demand of the current, I guess, just normal stuff like plastic?
Yeah, I think so. Well, this one is heavy because it's a comfortable chair, but there are designers that have made chairs in aluminum which are extremely light. Probably not as light as the plastic one, but certainly with the same feature that you could expect, like the fact that you can staple them one above the other, the colors I did mention, the flexibility as well of the backrest. Yeah, but will be with different cost drivers, of course. We do not always compete versus plastics. It's one of the material we compete with, but depends on the application. Yeah. It can be lighter than that one, that's for sure.
Yeah, I think in the case of the plus, it's quite challenging to like meet the requirements like a product that you just buy and put on your wall. But my idea was, like, I did some workshops where we collected the material close to the site and we mixed on site. So that's one way of limiting the logistics. And currently I'm working with Cool Bricks, which is a company who makes bakstenen,
Bricks.
bricks in Uganda from cow dung and clay, and we are developing panels because actually a lot of people they want a cheap and a fast house. So you have to also think your material into these demands. So we try to develop like a panel system that can be built up really quick, but is still as sustainable as possible, and using like local materials like clay and maybe banana fibers or whatever.
Okay. You had a question, huh?
Yes. Jacob from Aalsmeer, and I'm a grower. I grow plants. And I want to ask you, maybe it's a study to study about miscanthus, to combine it with your materials. That's one. And the other thing to you, what's the energy content of 1 kilo of aluminium in the traditional way and 1 kilo of aluminium in your way?
In energy is the same, but in environmental impacts, in carbon footprint, so this one for the raw material is 0.4. If you will take primary aluminum, for instance, from China, that will be 20, and the worldwide average is 14.7. So yeah. So we consider the raw material, the post-consumer scrap, as having no burden. It's zero carbon footprint because it has been used in a previous life. So the 0.4 is the remelting, then transport, sorting, transport, remelting, and then you have the 0.4.
Okay. Are there any more questions? No. Well, I'm so happy that the two of you are... Oh, sorry. Yeah,
I'm a bit slow. Can you think of a way to help each other?
Well, her methane.
Yeah, good question.
Yeah, the methane, if we can have it. The methane coming, the gas coming from the poop. It burns, so it can be transformed into biomethane. And well, yes. But the approach is great. There are a lot of similarities. The way you put that into perspective, your reflection, that's, I think, something the industry can learn from the young designers.
And how is that for you, when you look from a young designer's perspective to a bigger company? What can you
I think
do for him, and what can you learn?
I think what I could learn is, because I'm often very optimistic and I can be quite naive in that, so I also don't have so much real life experience in terms of the market and what can make it to the market and what are the requirements that the product needs. So I learned during the years that it's good to already talk to people who have much more experience than me in the industry to maybe avoid some side paths, even though I think it's important to also make mistakes and make your own experience. But I think I could learn a lot from the experience in terms of making a sustainable product. Yeah.
And never lose being naive, because it's also a superpower.
Yeah, you need it.
You need it. Sometimes you need to do naive things and just try it out.
You're working now for Cool Bricks. Can you tell a little bit about this next step? What is different than what you're doing here?
I'm not a designer anymore. I work in material R&D, research and development, which I didn't study, so it's a bit of a challenge. But I think, I will learn a lot. I'm working with Jask, who actually I quoted in my publication about this project, which is like a cycle complete, which is really great. He did a study at the TU Delft about the waterproofing effect of cow manure. And I guess, yeah, we are scaling it up. Cool Bricks is already building houses from bricks made from cow manure in Uganda. And for me, it's really exciting to bring it into the real world. It's also challenging, of course, because design has this kind of thing that you put it here and it looks like a finished project, but it's actually just a prototype, of course. So I'm facing also the struggles of actually making it real and accessible and cost efficient and all these things. So but I'm really grateful and excited that I can actually bring that passion, which is like so niche, into actual work.
Yeah, because you were also working on another project, right? Which is also exhibited here.
Yeah, a lot of projects going on. But this project is like a little excursion because now I live on Sicily and I really like to work with the place where I am and to see what is actually there and what can we make from it. So it's like an exploration of the materials in Sicily, for example, volcanic ash or different types of soils. And once you understand how to make a plaster, it becomes like a Tetris. So you only need to combine different sand and clay. And so it was more like an experimental study of what actually all can become a building material, what is just in the earth.
Wow. And you, Jean-Marc, what would you like to do for the future?
Well, we are working on the next evolution, or the next version, not version, but it's a secret. It will be provocative. Because we did the 100R, then the R100. So, but it will be a provocation to the industry, but you have to wait 1 year because I cannot tell what it is. I'm not allowed to say it.
Yeah,
it's a hint. No.
It's made from
Well, the hint is that it will be provocative. Yes.
Okay, and when will you show it off?
In 1 year.
In 1 year.
Yes.
We keep you to that. Okay. Well, thank you so much. We also have Hans, who is our regular guest. And Hans is always making a summary. It's actually a bit of a gift also to you as speakers. Hans.
Thank you. I enjoyed your presentations. And I think the first thing that comes to mind is the fact that when designing and when engineering on products, you should never focus on one aspect only. So cross-fertilization between design and engineer, cooperation, and I would advise the square approach, which is not square in the sense of civilian, but meaning look at the product and the designing process from the viewpoint of the impact on humans, on the organizational aspects, how do you organize this, on the technical aspects, so the technology around it, and the economic aspects. Because what you very often meet with a new product is that everybody starts talking about the money. And money is the one thing you can never eat. So if we want to have a future, we will have to make it like you are working. Oh, thank you very much. And the other thing is, I like shite. Many years ago, I used it as an anagram for the creative process. But Microsoft decided that the word shit could never be used in a mail or so. And then I thought up the idea, why don't I make it shite? So I just add the E, which is English and Irish for shit. It's like the German Scheiße, yeah? And then I used it as an anagram for the SH, means see and hear. That's the analyzing part. The I is invent, ideas. The T is try out, experiment. And the E is experience. So this four-step process takes care that you first make a good analysis, but then you are becoming naive. You just generate ideas. Impossible ideas are the best ones because they're really new. if you want to innovate, you must never come with something which has been thought of before. And I feel in your approach, both of you, that somehow you got that knack. Thank you very much.
Thank you, Hans. Thank you. Well, we will have some drinks in the bar. And everybody who would like to join for dinner, we also have a special Innovation Café dinner. We will keep the conversation. The speakers will also join. You can tell it to Zoe in her pretty dress over there. And she will get it arranged for you. So thank you very much. And I wish everybody a lot of shite, I guess, Hans. And enjoy your evening. Thank you. Thank you very much.